Hi, my name is Rick Hartwig. I'm the Built Environment Lead for the Institution of Engineering and Technology. I'm really delighted this morning to be talking to Hagop Heath-Matossian, who is with a company called BowTie Construction. We first met in March last year, had a conversation with him at that event, and we're now following the story of what they have done in the design competitions. And the project that's materializing. The aim of the design competition was to develop new approaches for high performance, scalable and cost-effective net zero retrofit solutions focused on apartment blocks. Hagop, maybe you just want to introduce yourself briefly and your organization.
Yeah, thanks, Rick. Thanks for having me here today. So I'm the innovation director. I joined the company as the business development manager about 5 years ago. And we're focusing more and more on large scale retrofit, volume retrofit. We've got history of as being a passive house contractor. We've built many passive houses and passive house retrofits in and around London. And that has dovetailed nicely into EnergySprong. So lots of our passive house experience and retrofit knowledge is going into our EnergySprong retrofits. I guess our landmark project, you can see kind of in the middle of the screen there, the brown timber building is Max Fordham House. That is built as a retirement home for the renowned building services engineer and Spitfire pilot who founded Max Fordham LLP. And that has no wet heating system. In fact, no heating system at all. It basically keeps itself comfortable throughout the year by having a very, very efficient thermal envelope. And we've won 2 RIBA awards for that building and CIBSE Project of the Year.
Thank you. The project you focused on is looking at a retrofit solution, a deep retrofit solution, I should rather say, for Treadgold House in Lancaster West Estate in London. Maybe you just want to talk through the broad concept of what you're trying to do at Treadgold House.
Yeah, a bit of context on the project. The Lancaster West Estate, they always planned to refurbish the whole estate. And then when the Grenfell tragedy happened, it kind of shifted the focus of that. And you can see Treadgold House is right there in the shadow of Grenfell. So the focus with this refurb and this design was to bring Treadgold House to net zero carbon, but to do it in the most fire safe possible way. So from our starting point, we wanted to make sure that we'd meet 2018 amended building regulations, which were amended as part of the Grenfell tragedy to have a very strong Euro class fire rating. So you can see here a very dated 60s block. It's so dated, in fact, that these flats actually have chimneys for coal fires, so they have fireplaces. And it's just in dire need of some love.
So the love you're referring to is essentially cladding the building and doing some interesting things to the building. Maybe you can just share with us briefly the concept, the EnergySprong concept that you've applied here, if it is indeed that.
Yeah, indeed. Yeah, it is EnergySprong, and it can also be passive house compliant, depending on how far the client wants to go. So the broad brushstrokes are: we would remove the existing balconies, which constitute an extreme thermal bridge, and that is a way for heat. They act as a heat sink, effectively, sucking heat from the core of the building out to the sort of cold exterior temperature in winter. So we remove those balconies, and we then fit external wall panels, which are steel frame structure, insulated with about 150 mil of rock wool, and they are fitted to the whole of all of the elevations going around the building. We then fit new freestanding off-site manufactured steel balconies. So the weight of those balconies goes down to the ground and they're located to the building. We fit a new warm roof, which creates that sort of cheese wedge shape that you can see from the steel frame on the drawing. And in that roof becomes a new loft for services equipment. So air source heat pumps and ventilation equipment. Everything's manufactured off-site. It's brought on-site on a just-in-time basis. And another view here showing those balconies. These balconies are double the size of the previous balconies, and that was important to us as a way of really giving the residents something beyond just saying you're now going to live in a net zero carbon building and you'll have lower heating bills. We wanted to increase everyone's amenity space and for that space to be more pleasant and more useful.
I think at the end of the day, the project is really aimed at helping the life of the residents, and fuel poverty is a real issue right across the country. We have such energy inefficient buildings that people are spending more than they need to on unhealthy buildings, to a lot of power to warm, heat unhealthy buildings. Maybe you can just talk through some of the opportunities that have come out of the project.
Yeah, absolutely. I mean, I came into sustainable construction really as an environmental activist. And I saw this as one of the main ways we could really help fix some of the global problems, you know, going beyond trying to push government to do things and waving placards at demonstrations. And the thing that really attracted me to Passive House is, and this is one of the lesser known things about Passive House, but in order to certify a Passive House building, during the design process, the modeling essentially won't let you pass your design unless you design a building in which all surfaces never fall below 19 degrees. And that eradicates damp and mold. And it also means that even if you don't have any money at all to run your heating system, your house will still stay at a pretty livable temperature. And the design for Treadgold House, you know, we used the Passive House planning package and modeling and all our Passive House knowledge from 10 years of delivering these projects. So we know that even if someone doesn't have enough money to run their heating for the month, they're not going to be freezing cold and they're not going to be unwell as a result of being cold. So this is a massive gift, I'd say, to the residents of this building. And anyone that ends up living in one of these types of buildings.
So you've obviously taken out the gas. Emissions has dropped considerably. What's not known is the amount of nitrous oxides that is, or what's not generally recognized, I should perhaps say, is the amount of nitrous oxides generated by the conventional boilers. These numbers are quite staggering.
Yeah, it's interesting because it's something that, I mean, gas somehow has got this reputation of being a really clean fossil fuel. Maybe it's the cleanest, but actually it is still pumping out, you know, combustion of gas still pumps out a lot of quite harmful toxins. Nitrous oxide, no, is poisonous. It's the same, one of the same emissions from burning diesel. And then the figures on the screen right now are what we calculated as being the result of 1 year's gas consumption from the 38 Treadgold flats. So totaling 417 tons of CO2 and 1.2 tons of nitrous oxide. And so another benefit, again, often not talked about, of a net zero carbon retrofit, but so once the retrofit's completed, these gases are no longer being emitted. So if you're a resident and you support this retrofit and you say, yes, I want it, you're actually taking active steps to improving your local environment. You know, you're improving the quality of the air where you live. You're going to be reducing incidences of asthma, and it'll smell nicer too.
Yep. And obviously the impact on the energy spend to heat that space is really significant.
Yeah, it is. So I've tabled here some of the kind of typical building types that we're used to seeing. For most people, it's going to be the Victorian house, somewhere between the Victorian house and the new build house, are the typical energy consumptions of buildings in the UK. You can see what Passive House would typically deliver. And then the Treadgold House BowTieSprong is even better than that. And that is because when you retrofit a large building with many flats, and many of these flats will only have a single external wall, you get a huge increase in efficiency by the fact that, you know, you're treating the elevation, you're treating the outside of the building, but there are many individual units within that building. So the kind of passive internal heat gains that these buildings have from things like fridges and warm showers, once you insulate the building, they're kept in the building really well.
Yep. I support that entirely. The one thing about the project, the whole idea was that the residents would remain in situ during the life of the project. That must have been quite a hard sell.
Yeah, well, that's part of the energy sprung concept. And it's part of what makes it attractive to councils, because if a council wants, or a housing association wants to refurb a whole block, moving everyone out of those flats, putting them in temporary accommodation and bringing them back, adds a huge amount to the budget, and it's a huge logistical challenge. Local authorities don't have empty blocks sitting around to put people in temporarily while doing refurb work. So the resident engagement is really important, and it goes down to explaining to the residents what it is that's being proposed, and also involving them in the process as far as co-design. So we partnered with Social Landscapes, who are permaculture design specialists, and permaculture is all about earth care, people care, and fair shares. So it's about making sure that everything gets looked after in the design, and it's about asking residents what they want from the retrofit, and that's where this imagery came from, is from that information gathering process, looking at the existing garden, how it could be improved, what residents really wanted. And the sort of main response we got was a bit of a playscape, because a lot of the kids are playing football right now in that car park and it's not very safe. So really a playscape for them. And one thing that, would never have probably thought of if we hadn't asked the residents, but it was about making it more accessible by creating a path, which you can see in this drawing, that really frames the whole garden. And that was to create level access for elderly people, safe access, and really just to create a bit of a walking route. And you can imagine kids, toddlers, taking their first steps around this garden. This garden is the nearest green space for the 38 flats. So really about making this space as useful as possible, and as pleasant and fun as possible, for as many of the residents as possible.
You've taken a similar approach to the balconies. I was fascinated by the amount of stuff you wanted to do on the balconies.
Yeah, so we wanted each resident to be able to customize their balcony for their own lifestyle. Some people might want to store bikes on their balconies. Some might want to grow food. You can see the middle side, there's some wire coming down, and that's really to prevent pigeons from being able to access the balconies, because there is a big problem. Again, we would never have known this if we hadn't asked the residents, but a lot of them have a problem with really invasive pigeons flying into their windows even and stealing their food from their kitchens. So that wire would be an option for certain people, and it also makes it a little bit safer if you're someone with a 2-year-old or a 3-year-old who loves climbing. Kids are known for that. You would feel safer knowing that wire was there. So the manufacturing spec of each balcony would be the same, but there would be these certain customization points, and the residents would be given a choice of how to customize it. And it even goes further into having a volunteer gardening project, where the residents would be sowing seeds for certain plants, and those plants would then end up going into the planters on their balconies. And all of this has all the knock-on effects of giving residents a chance to meet each other and make friends, and residents who maybe would never mix, maybe they're from other ends of the block, maybe they're very different ages or different backgrounds, they mix and they have this common shared experience. And all of that, it leads to increased psychological resilience, and just knowing your neighbors more and getting on with your neighbors more will always make you feel happier and safer in your home.
The real challenge, I think, that the sector faces, that's the housing sector faces, is to scale this up in such a way. You're talking here about 38 flats, great concept, great idea, 38 happy families. But we published a white paper 2-3 years back that was looking at scaling up of deep retrofit and how we could do it. And what are your plans for that?
So we were approached by Osborne, who saw some of the press around this concept, and they asked if we would partner with them to help bring net zero carbon retrofit to a much bigger scale. And that's always been our goal as a company. We've previously done kind of individual houses, some quite big, some quite small, but we wanted to scale up. We don't want to do just one BowTieSprong retrofit a year. We want to do, 5, 10. And so working with a larger contractor where we're more focused on the scoping and the design and the cost estimation as part of the design process and the energy modeling as part of the design process, we can then work in partnership with Osborne, who can then actually build them out.
The technology you've adopted in running this mixed reality, you spoke of mixed reality app that you had developed. I'm rather intrigued by that.
Yeah, so this started as us wanting to be able to document our sites so that we would know where our service runs are, pipes, electrics, junction boxes, so that later down the line, if the client wanted to make changes, or even during the construction process, sort of, once the finishes start going on the wall and the client decides they want to move a socket or add a new socket, we could save ourselves a huge amount of time and expense by knowing where all these different elements were. So we now document all our sites with 360 photos at first fix stage. We then do this again at completion. And it means that the client then can access this X-ray 360, and they can stand at the spot where the photo was taken, and they can move their smartphone around in order to see exactly where the service runs are.
And finally, just to touch base on the costs implications of this. There's a lot of negative criticism out there about deep retrofit and how much it costs. You've made quite a strong statement in that regard. Perhaps you'd like to share that with us.
Yeah, I think, people really need to have a bit of imagination and they need to be a bit less pessimistic. We are at the beginning of the process. We have only got a few hundred or a few thousand deep retrofits in the UK. It's logical that by the time we have 10,000 and 100,000, these costs will drop. There'll be a lot more people doing this kind of work. It won't be so alien and so specialist. There will be tried and tested details and products on the market. And at BowTie, we're developing some of those products and services to help increase reliability, increase programmability, so actually getting a real handle on how long each stage will take. So it's all about industrializing the process, using modern methods of construction. Innovate UK are really strongly supporting innovation in all these areas so that we can bring down the costs of net zero carbon retrofit and make it much more reliable.
And also, as you point out in the slide, a much more investable proposition, because the finance is a key missing ingredient at the moment. Because of the high cost, investors are staying out. They don't want to be involved. They just don't see it's worth it. But there are other benefits to that, as we've spoken about before.
On the finance, on noting finance, one of the reasons that EnergySprong is focusing on housing associations first is because they take a very long view on the maintenance of their buildings. Yeah. They'll have the planned maintenance, budgeted for 30 years into the future. So if you can do a retrofit, and you can then take some of those planned maintenance costs away because you're improving building fabric, and you're not just doing a band-aid here and a band-aid every kind of 5 years. You're actually installing something that's much higher quality and going to last a lot longer. Then it makes sense to put more money into that retrofit, and then your payback period is also a lot longer. So that currently we say these retrofits will pay themselves back in 20 or 30 years. But as the costs drop and as more projects are delivered and there are more products and services to bring those costs down, obviously that payback period will reduce.
Yeah, which is why when we look at what you talk about, speed, quality, efficiency going up, disruption, cost, and inconvenience going down, big factors in making these decisions for all involved across the supply chain.
Massive win for everyone. The residents don't have all the noise and the upheaval of the retrofit process taking as long. The actual components are manufactured to a very high accuracy because you don't have wind and rain, and there's much less waste.
Yeah, which is really what we need in the industry. We need to make some impact. I'd like just to say thank you to Hagop for joining us this morning, for sharing us the developments on this really, really exciting project. And I do look forward to talking to you again as we follow the development of Tread Gold House Deep Retrofit.
Thanks, Rick, and thanks to the IET for having us.
You're most welcome.